Very good afternoon to all. This is Deepak Kumar, Assistant Professor in KIET Prof institution. Today we will discuss the concept of 8255 programmable peripheral interface. So before starting this topic, first of all, it should be very clear that why we use this 8255 programmable peripheral device. Actually, let's suppose if microprocessor wants to communicate with peripheral devices. So microprocessor basically accepts binary informations, while sometimes the peripheral devices may send ASCII informations. Just like a keyboard, it will send the ASCII informations. So if the ASCII information or ASCII character is directly sent towards the microprocessor, so microprocessor will not understand that which type of information actually he is getting. So what's going on? We generally use an interface device that convert binary information to ASCII value as well as the ASCII value to binary information. Or we can say that it converts the data of microprocessor as per the peripheral devices and convert the data of peripheral devices as per the microprocessor. So for this purpose we generally use this 8255 interface. Now the next question is that why it is known as programmable peripheral interface. Actually here in this particular chip the user can perform their coding, and on the basis of their coding he will control this particular chip. So that's why it is known as 8255 programmable peripheral interface. Okay, so now in this particular slide we will focus on these three things. The first one is the features of 8255, the next one is block diagram of 8255, and the next one is your operating modes of 8255. So if we are talking about features of 8255, so in this 8255 IC we have actually three ports, that is port A, port B and port C. Out of these three ports, port C is basically divided into two parts, that is upper half part and lower half part. Each port is of 8 bits. So port A have 8 bits, port B have 8 bits, 8 lines, and port C have 8 lines. So on these 8 lines the different peripheral devices are connected. Out of these three ports, port C is again divided into two parts, that is upper half and lower half part, and each of 4 bit informations, each having 4 bit information. So each port can be programmed as an input port or output port. So what does it mean? Let's suppose this is your microprocessor and this is your peripheral devices, and here we have 8255 interface. So let's suppose if the microprocessor basically sends the information to peripheral devices, then the communication is like this. In that particular case 8255 will be considered as output port. Okay, next, if the communication is like this way from input output port to microprocessor, then in that particular case the port of 8255 will be considered as input port, that is your input port. Okay, so it depends upon which mode actually we are using. So this 8255 port will be considered as input port or output port. It totally depends upon that which mode we are using. So actually we are using two different modes. The first one is bit set reset mode and the next one is your input output mode. So hello friend, this is Deepak Kumar, Assistant Professor in KIET Prof institution, Ghaziabad. In this lecture we will discuss the concept of 8255 programmable peripheral interface. So before starting this topic, first of all it should be very clear that why we use this 8255 programmable peripheral interface. Suppose that if we want to perform the communication between microprocessor and peripheral devices. So sometimes microprocessor actually access the information in binary format, while some peripheral devices may use ASCII characters to send the information to microprocessor. So let's suppose if peripheral devices directly send the ASCII character to microprocessor, at that time microprocessor will not understand this ASCII information because microprocessor only knows the binary information. So we require a peripheral, an interface device through which we can convert binary information to ASCII or as well as ASCII information to binary. So for that interfacing purpose, we actually use this 8255 programmable peripheral interface. Now the next thing is that why it is known as programmable, because the user can perform their coding, their own coding. On the basis of that, he or she may control this particular device. So that's why it is known as programming peripheral interface device. So now we are just discuss these three things. The first one is the features of 8255. Next one is block diagram of 8255, and the next one is operating modes of 8255. So if we are talking about the features of 8255, so 8255 is basically an IC where total 3 ports are there. That is port A, port B and port C. And in each port we have 8 lines are there. In each port we have 8 lines. On these 8 lines, the peripheral devices are connected with this particular chip, this particular IC. Okay, so 8 lines are there in port A, 8 lines are here in port B, 8 lines are there in port C. So total 24 actually input output lines we have. So total 24 output lines we have in this particular 8255. Okay, out of these 3 ports, port A, port B, port C is again divided into 2 parts. That is port C lower part and port C upper part. Port C lower and port C upper part. So that is of 4-bit, 4 line. Each port has lower part have 4 lines and upper part have 4 lines. So as I told you that let's suppose agar we have 8255 IC, and let's suppose here we have microprocessor and here we have peripheral devices. Okay, and let the communication is like this. That means microprocessor wants to send information to peripheral devices, input output devices. Okay, so when this information is sent in this particular way, so at that time 8255 will be considered as output mode. So this will be considered as output buffer. So all these ports, all the ports of 8255 will be considered as output buffer. If the communication is like this way, in this particular way, so in this way the 8255 will be considered as input buffer. Okay, so when 8255 will be considered as output buffer or when it will be considered as input buffer, it totally depends upon the mode through which we perform the data communication. So the modes are, the first mode is bit set and reset mode, and the next one is your input output mode. In these 2 modes, input output mode is again divided into 3 parts. That is mode 0, simple input output, mode 1, strobed input output, and mode 2, strobed bidirectional input output. So on the basis of this input output mode, we generally identify that the ports are working as an input mode or it is working as an output mode. Okay, so these are the features of 8255. Now we are just moving towards the block diagram of 8255. So in 8255 we have different units. The first one is known as the data bus buffer. In data bus buffer, it is not necessary that we have only the data information, and the size of this data bus buffer is of 8 bits, and this 8-bit information may contain the data information, it may also contain the control information. So all these informations may be stored in this data bus buffer. So it depends upon the situation that microprocessor is sending the data information as well as the control information. If it is sending the control information, then the data bus buffer basically contains the control information. Okay, so that is your data bus buffer, and this is connected with system bus and with the system bus through microprocessor. So microprocessor will send the information with the system bus to the data bus buffer, and the data bus buffer uses the internal buses, and with the help of this internal buses, this information is received by the different port. Now the next one is your read-write control logic. So in here we have different pins. The first one is read complement, that is your active low signal. That is, if when it is 0, then here we just perform read operation. Read WR complement, that means when it is 0, then we perform write operations. A0 or A1 actually tells us that if we are performing read operations or write operations, so in which port we just perform this, in port A, port B or port C. So these ports will be selected via A0 and A1 pin. So A1 and A0 values will be, if it is 00, then port A will be selected. If it is 01, then then port B will be selected, and when it is 10, then port C will be selected. And when it is 11, then the control word register, then the control informations will be selected. So control word register is what? It's nothing. When the control information is there, the control word registers informations will be placed over there. Here we have control word register. Okay. So this is your control word informations, and on the basis of that we controlled this 8255 programmable peripheral device. Okay, so that is the block diagram of 8255. Now we are just moving towards the operating modes of 8255. So as I earlier told you that there are two types of mode. The first one is the BSR, that is bit set and reset mode, and the next one is your input output mode. Okay, when we are talking about this mode, when A0 and A1 value will be 1 1. When it is 1 1, that means we are talking about the control word information. Okay, so there are two different control word format which is specified two basic modes. The first one is BSR and the next one is your input output mode. Now we will discuss the register format for these two different modes. So if we are using bit set and reset control informations, so here the 8-bit registers basically contains this information. So the D7 bit basically identify that which mode we are using. We are using bit set reset mode or input output mode. Okay, so when the value of D7 is equal to 1, then bit set reset mode is active, and when this value is 1, then input output mode will be active. Okay, D4, D5 and D6 will be your don't care conditions. That means we can take 0 as well, 0 and 1. D1, D2, D3 will identify the port C bits, which that means for which bit we are talking about of port C. So if B1, B2 is, if D1, D2, D3 bits value is 0, 0, 0, that means we are just talking about bit 0 of port C. If it is 0, 0, 1, that means we are talking about bit 1 of port C. And similarly bit 2 of port C, bit 3, bit 4, bit 5, bit 6 and bit 7. So this basically identify that for which bit of port C we are generally talking about. Okay, so let's suppose if we are talking about bit 3. So what is the value of D1, D2, D3? The value of D1, D2, D3 is 0, 1, 1. Okay. So bit 3 is what? Bit 3 is your 0 or bit 3 is 1. That is actually identified via D0 bit. That is set oblique reset complement. So if the value of D0 is equal to 1, that means bit 3 is 1. And if this value is 0, that means bit 3 is your 0. So that is actually your bit set and reset control word. Okay, now we are just moving towards input output modes control word format. So if we are talking about input output control word format, so here again the size of control word register is of 8 bits, because we know we are just using the data buffer for storing the control information, and the size of data buffer is of 8 bits. Okay, so this is your 8 bits format. So this actually identify that port A, port B or port C as well as group A or group B. So for which mode we are using, input mode or output mode. That means it will be considered as input buffer or output buffer. So if D0 bit is 1, that means port C lower part will be considered as input mode. Okay. If D1 is 1, that means port B will be considered as input buffer. If D2 is 1, that means group B is mode 0, mode 1, which mode we are using. Okay. If D3 is equal to 1, that means port C upper part is equal to 1. That means port C upper part will be considered as input mode. If port A is 1, if D4 bit is 1, that means port A will be considered as input mode. If D5 and D6 will be 0, 0, 0, 1 and 1x, then it will identify, that means which mode we are using, mode 0, mode 1, mode 2. And D7 bit actually identify that which mode we are talking about, bit set reset or input output mode. So if this value is 0, then it is your bit set reset mode, and if it is 1, then it will be considered as input output mode. Okay, so that is your modes of 8255 peripheral interface device. So these are the references for the lectures, and thank you so much.